The Green Tech Blueprint, Unpacking IE 1680, the hidden rules of your devices.
Have you ever wondered who actually decides if a computer is green? In this deep dive, we explore the fascinating invisible rulebook of tech sustainability, the IE 1680 family of standards. We decode how environmental performance is graded for everything from your highly personalized desktop monitor to that legacy fax machine sitting in the corner. Discover why some tech standards become the unquestioned law of the land for massive federal purchases, while others fail in dramatic ballot votes and are archived forever. Whether you are prepping for a tech procurement meeting, tracking the evolution of social responsibility in tech, or just insanely curious about green computing, this deep dive reveals the hidden infrastructure of sustainable electronics.
IE 1680, Green Computing, Sustainable Electronics, Environmental Performance, Tech Standards, Desktop Sustainability, Social Responsibility in Tech, IE Standards, Electronic Products Assessment, NSF 426, UL Empowering Trust.
Okay, let's unpack this. Have you ever looked closely at the physical devices that govern your day?
Oh, all the time.
Right, like your tablet, your television, or maybe that massive, complicated office printer you rely on. And have you ever wondered who actually checks if it is environmentally friendly?
Most people just look for the sticker.
Exactly. We all see the little eco stickers on the packaging, and we are constantly bombarded with these sleek marketing campaigns about green computing. But who is the invisible referee making sure those corporate claims are actually grounded in reality?
That is the million-dollar question.
Yeah. So today we're doing a deep dive into what you might call the Green Tech Blueprint. Specifically, we are unpacking the IE 1680 family of standards and the hidden rules of your devices.
It is a fascinating space to dig into.
It really is. And the mission for today's deep dive is to read between the lines of a really fascinating yet highly obscure piece of source material. It is a Wikipedia article.
Not just any article.
No, not just any article. It is specifically categorized as a stub. And in the taxonomy of the internet, a stub is a short, highly technical entry that on the surface looks like, just a dry, incomplete list of engineering codes.
It looks like something you would skip right over.
Totally.
Yeah.
But if we actually take the time to read between those lines, this tiny text reveals the invisible rulebook governing sustainable electronics. We are going to decode how environmental performance is graded for the technology you interact with constantly.
The concept of a Wikipedia stub is actually the perfect metaphor for how we interact with technological standards in general.
Oh, how so?
Well, they are entirely invisible to the average consumer. They seem incomplete or esoteric, yet they support the massive physical weight of our digital existence. What we have in this specific source material, literally just a few sentences and a short list of footnotes, contains an entire dramatic narrative.
A dramatic narrative in an engineering stub. I love it.
It is true, though. Hidden in this brief text are the mechanics of massive industry consensus, the heavy hand of federal regulations, and even the messy political reality of failed archived rules that never even saw the light of day.
Which we will definitely get into.
Oh, absolutely. It is a microcosm of how social and environmental responsibility in the tech sector is negotiated and codified. When we look at IE standards, and for those who might not have the acronym memorized, that is the Institute of Electrical and Electronics Engineers, we are looking at the foundational architecture of the modern world.
Right.
They are the agreements that dictate how the physical components of our lives are built. But the fundamental tension hidden in this stub is this: what happens when you try to standardize something as deeply complex, moving, and subjective as an environmental impact assessment?
I am so glad you defined the acronym right out of the gate, because we are dealing with a world of heavy jargon here. And for you listening, I want to establish right now that this isn't just an abstract thought experiment
Not at all.
or a dry recap meant only for IT procurement officers. These are the actual literal rules that dictate the physical reality of the devices you touch every single day.
From the screen you are looking at right now to the battery powering it.
Exactly. They dictate how those devices are manufactured, how they manage power while you use them, and how they are ultimately disposed of when you are done with them. So let's jump directly into the core of the text.
Let's do it.
The article defines the IE 1680 family as, quote, sustainability standards dealing with the assessment of environmental performance of electronic products.
A very straightforward definition.
Yeah, very dry.
Yeah.
But right after that dry definition, the text drops a massive sweeping claim. It states that IE 1680 is the de facto standard for green computing at the desktop level.
And the semantics of that phrase are absolutely crucial here. De facto standard is doing a tremendous amount of heavy lifting in this text.
Because it is a very specific legal-sounding term.
It is. If we analyze the terminology, de facto translates from Latin as in fact or in practice. This is fundamentally distinct from a de jure standard, which is a rule mandated by law from the top down.
So de jure is the law.
Right. A government passing a law saying all cars must have seatbelts is a de jure standard. When the text explicitly labels IE 1680 as the de facto standard, it outlines a completely different mechanism of power.
Okay, walk me through that.
Well, it implies that this framework wasn't necessarily mandated by a single godlike regulatory authority from the very beginning. Instead, it suggests a scenario where the notoriously competitive, fiercely independent tech industry collectively surrendered to it.
Surrendered to it. That is a strong way to phrase it.
But that is what happens. They adopted it as reality because it worked, or perhaps because market forces aligned in such a way that ignoring the standard became an economic impossibility. It became the ruler by which all other electronics are measured simply through overwhelming practical adoption.
Wait, but if I'm understanding this de facto concept correctly, it means there wasn't a congressional hearing or a global summit that legally forced HP, Dell, and Apple to build computers this way right off the bat.
Exactly. No global summit dictating the rules on day one.
It implies an organic surrender by the market. But why would fiercely competitive tech giants voluntarily surrender to a single environmental rulebook if they didn't legally have to? Especially a rulebook that presumably makes manufacturing more difficult and more expensive.
Because the friction of not having a standard is ultimately more expensive than the burden of compliance.
Oh, that makes sense.
Think about the global supply chain. If a manufacturer is sourcing parts from Taiwan, assembling in Mexico, and selling in Germany, Canada, and the United States,
They are dealing with a nightmare of regulations.
a total nightmare. They cannot afford to navigate 50 different localized definitions of what constitutes a green computer. A de facto standard emerges when the entire ecosystem, the manufacturers, the parts suppliers, the corporate buyers, and the engineers, realizes that a unified baseline is a prerequisite for doing business at a global scale.
So they just agree to agree.
Basically, the industry surrenders to the standard because the alternative is chaos. It provides a shared language of sustainability.
That makes the phrase de facto sound a lot less like a casual accident and more like a hard-won treaty. Now, looking at the space this treaty conquered, the text is very specific. It says it's the de facto standard for green computing at the desktop levels.
Yes, the desktop level.
But this is where I want to push back a little bit on the logic of the rollout. We think of the desktop as our personal workspace. It is inherently modular: a monitor, a chassis, a keyboard, maybe some peripherals.
Lots of moving parts.
Right. Which means standardizing it is an exercise in managing millions of disparate consumer choices. But is the personal desktop really the most critical place to start?
That is a very valid question.
Because I would argue that massive enterprise-level servers and industrial computing infrastructure use exponentially more power than my single home office monitor. Wouldn't it make more sense from a pure environmental standpoint to tackle the massive industrial power drains first, rather than focusing on the desktop level?
Your pushback highlights the exact tension inherent in creating a global standard. It is a question of strategy versus pure impact.
Strategy over impact.
Right. If we look at the focus on the desktop level, we have to view it through the lens of ubiquity and critical mass. Yes, a single industrial server farm uses exponentially more power than a single office building full of desktops.
Exponentially more.
But the desktop is the consumer-facing front line. It is where millions upon millions of individual purchasing decisions are made every single day. For a standard to become truly de facto, for it to gain that unstoppable market momentum we just discussed, it needs visibility and volume.
So it is about getting it in front of as many eyes as possible.
Exactly. By targeting the desktop level first, the IEEE 1680 family focused on the devices that are manufactured in the absolute highest volumes on Earth and that sit directly in front of the largest number of human beings.
It's basically a massive psychological campaign.
It is about standardizing the psychology of the market as much as the hardware. If you can successfully standardize the environmental assessment of the desktop, you have effectively trained the entire global supply chain to operate within your framework.
You train the muscles.
You establish the infrastructure of compliance, you build the roads first, and then you start worrying about the heavy cargo.
Okay, establishing the infrastructure of compliance, that leads perfectly into a very telling reference I noticed in the footnotes of the article.
The footnotes are always where the best details are hiding.
Always. Footnote number 4 cites a book to back up this claim about 1680 being the de facto standard. And the title of the book is Information Systems Theory, Explaining and Predicting Our Digital Society.
A very heavy title.
I found that title incredibly striking. How does a set of dry engineering rules about hardware tie into the grand concept of explaining and predicting our digital society?
The inclusion of that specific book title in the footnotes reveals something profound about the true nature of tech standards. We tend to think of engineering standards as purely retrospective.
Like grading a test after it's been taken.
Exactly. A way of measuring what has already been built. But the title, Explaining and Predicting Our Digital Society, suggests the exact opposite. A standard like IE 1680 explains how our physical hardware currently interacts with the natural world.
Right, the current state of things.
It quantifies the energy draw, it catalogs the restricted toxic materials, it maps out the recycling pathways, but more importantly, it predicts the future.
Because it forces the industry's hand.
Yes. Standards dictate the roadmap for manufacturers. They predict what the devices of tomorrow must look like in order to go to market.
Give me an example of that.
Well, if an updated standard dictates that a desktop monitor must use a significantly higher percentage of post-consumer recycled plastic, it literally predicts a future where global supply chains must pivot, innovate, and invest to provide that specific type of plastic.
They have to build the factories to make the plastic to meet the rule.
Precisely. The rules we set for hardware today, physically and economically, shape the societal infrastructure of tomorrow.
You are literally legislating the future of physical materials.
Yep.
Let's look at how that legislation is actually broken down in the text. The stub categorizes the 1680 family into a few distinct parts, which I'll call the core trinity of the standard.
That is a good way to frame it.
The first one listed is Standard 1680.1. The text defines this as the standard for the environmental and social responsibility assessment of computers, tablets, and monitors.
The heavy hitters of personal computing.
Exactly. Now, if you look at the footnotes, this specific standard was updated in 2018. And I'm looking at this 2018 update, and it suddenly adds the phrase social responsibility to the criteria.
A very significant addition.
That feels like a massive conceptual leap to me. The overarching definition of the entire 1680 family only mention environmental performance.
Right, physical metrics.
It is one thing to measure how many watts a monitor draws in sleep mode, or whether a battery contains lead, but measuring the ethics of a global supply chain?
It is a whole different ballgame.
How does an engineering committee, people who deal in voltage, thermodynamics, and material science, even begin to standardize human ethics?
That is the central friction of modern engineering, and arguably the most significant evolution documented in this text. The transition from purely physical metrics to ethical metrics is incredibly difficult to quantify.
I would imagine so.
But this raised an important question. Can you truly separate the physical environment from the society that inhabits and extracts from it?
They are completely intertwined.
Based on this 2018 edition, the IE Standards Committee clearly decided the answer is no. We can infer that the definition of a device's footprint evolved, is no longer viewed merely as a measure of power consumption or chemical composition.
It's bigger than that.
The human element involved in its creation is now inextricably linked to its sustainability rating. Social responsibility in this context implies a profound realization. A computer isn't truly green if the human labor practices used to mine its rare earth minerals or assemble its microscopic components are exploitative or dangerous.
But how do they ballot on that? I can easily imagine engineers arguing over the efficiency of a power supply. You can test that in a lab. You can plug it in and measure the output.
It is binary. It passes or it fails.
Right. But how do you test social responsibility? If I am an engineer sitting on this committee, how am I defining a standard for fair labor practices in a cobalt mine halfway across the world?
You are hitting on exactly why this 2018 update was likely a massive battle to establish. Standardizing social responsibility requires engineers to step outside the laboratory.
Right outside.
They have to integrate international labor laws, human rights frameworks, and corporate auditing processes into their technical specifications.
So they are suddenly playing the role of human rights auditors.
Essentially, yes. It means the standard must outline acceptable practices for auditing supply chains, tracking the origin of conflict minerals, and verifying worker safety protocols at the assembly level.
That is incredibly complex.
It forces a hardware manufacturer to become intimately responsible for the sociological impact of their entire procurement network. The 2018 update signifies a total paradigm shift. It moved the standard from a purely ecological assessment to a holistic, ethical assessment of the entire life cycle of the product.
It acknowledges that the machine is not just the sum of its parts.
It is the sum of the human labor that built it.
It fundamentally changes the definition of what a computer is. It means when you, the listener, are scrolling on your tablet right now, the invisible rules governing that device are deeply concerned with both the carbon emissions it creates and the human rights record of the factory that sourced its screen.
It is an incredibly broad mandate.
So we have 1680.1 handling the heavy lifting of desktops, tablets, and human ethics. If we step out of the personal cubicle and into the hallway, we run into the next major hurdle of corporate energy drain.
The copy room.
The dreaded copy room. That brings us to standard 1680.2. This one covers the environmental assessment of imaging equipment. And the text gives a fascinatingly specific, almost nostalgic list in parentheses.
Let me guess.
It covers printers, copiers, scanners, fax machines, multifunction devices.
Fax machines.
I have to pause here. The fact that fax machines are explicitly listed and regulated in this highly sophisticated environmental standard is wild to me.
It seems like a relic.
We tend to think of green computing as being all about cutting-edge cloud architecture and sleek laptops. Why is a rigorous engineering committee keeping a close eye on the legacy technology sitting in the corner of a dental office?
The inclusion of the fax machine is a wonderful grounding detail. It highlights the comprehensive, relentlessly pragmatic nature of these standards.
Pragmatic is a good word for it.
The IE understands that the physical infrastructure of the business world doesn't upgrade uniformly or gracefully. The tech industry loves to focus on the cutting edge, but the reality of global enterprise is that legacy devices remain plugged in.
They just sit there forever.
They sit in standby mode for years, they draw parasitic power, they consume physical consumables like thermal paper and specialized inks.
And when they finally break, they're full of weird chemicals.
Exactly. They require complex disposal. A comprehensive standard cannot afford to ignore the unglamorous technology that stubbornly refuses to die. Furthermore, if you look at footnote 8 regarding 1680.2, it references an Amendment 1 published in 2017 amending the original 2012 standard.
Right, so the rulebook is constantly being edited. But why issue an amendment 5 years later for printers and copiers? Is imaging equipment really evolving that rapidly?
Absolutely. Think about the transition from traditional massive laser toners to high-efficiency ink tanks.
Oh, right, the ink tank revolution.
Or the integration of wireless networking capabilities into every single printing device. Every time the core technology shifts, the environmental assessment must adapt to capture those new realities.
The rules have to keep up with the tech.
The Standards Committee cannot just write a rule in 2012 and walk away. These are living documents. If a new type of multifunction device suddenly requires a constant connection to a cloud server to operate, its power profile completely changes.
Because it's constantly pinging the network.
Right. The committee has to continually issue amendments to keep pace with the shifting reality of the hardware. It is a constant game of regulatory catch-up.
It is like trying to paint a moving train. So we have standard 1680.1 for the desktop and 1680.2 for the office copy room. Now we move right into the middle of your living room.
The entertainment center.
Let's look at the third success story in the text, standard 1680.3. This one was published in 2012, and it is the standard for the environmental assessment of televisions.
2012 was a long time ago in tech years.
Exactly. Think about this from your own perspective as a consumer. This standard was locked in back in 2012. If I think about the television I owned in 2012 compared to the massive, ultra-high definition, constantly connected, artificially intelligent screen dominating my living room today, the difference is staggering.
They are completely different species of machines.
How could a standard written over a decade ago possibly anticipate the televisions we have now?
That gap in time is precisely why establishing that environmental baseline in 2012 was so critical. Consider the trajectory of television technology over the last 10 to 15 years.
It has exploded.
The entire industry has been defined by a relentless arms race for two things: larger screen size and higher peak brightness, what the industry measures in nits.
Right, everyone wants the brightest TV on the wall.
Both of those features are inherently, undeniably power hungry. If left completely unchecked, an 85-inch high-brightness OLED television would draw an absurd amount of electricity,
It would be like running a space heater in your living room.
effectively neutralizing any other energy-saving measures a household might implement. By establishing a rigorous standard for televisions back in 2012, the IEEE created a vital, invisible check on that consumption.
A guardrail.
Yes. As the screens grew from 40 inches to 65 inches to 85 inches, the baseline environmental assessment ensured that the thermal and electrical efficiency of the underlying technology had to scale alongside the physical size.
So they couldn't just brute force the brightness by plugging it directly into a power plant.
It forces manufacturers to innovate not just in picture quality and pixel density, but in aggressive energy management and standby power reduction.
It is like putting a hard speed limit on a highway just before the auto industry starts mass-producing 800 horsepower sports cars. The cars get faster, but the systemic rules force the engineers to focus on control and efficiency so the whole system doesn't fly off the rails.
That is a great analogy.
Now, up to this point, our read of this Wikipedia stub has painted a picture of a very orderly, highly successful rollout. Desktops, printers, TVs, they all get their neat little numbers, their successful ballot votes, and their published standards.
It sounds like a perfect system.
The industry complies, the future's predicted, everything is working. But the final paragraph of this text suddenly shifts the tone completely.
This is where it gets messy.
It really does. It introduces what we can only call a graveyard of standards. It turns out the 1680 family is not a story of uninterrupted consensus. There is intense drama in the ballot process.
Behind closed doors.
Let's look at Standard 1680.4, which was supposed to be the environmental assessment standard for servers. The text flatly states that it failed in ballot and was superseded by NSF 426.
The phrase failed in ballot is incredibly evocative, especially when you find it in the dry context of a technical encyclopedia stub.
It is surprisingly dramatic.
It completely lifts the veil on how these rules are actually created. They are not dictated by an omniscient authority, they are fiercely negotiated.
Like a peace treaty.
A standard must survive a rigorous, highly contentious voting process by committees composed of industry stakeholders, rival manufacturers, environmental advocates, and independent engineers.
So everyone with a vested interest is in the room.
A ballot failing doesn't just mean a few people disagreed. It means consensus structurally broke down. The stakeholders could simply not agree on what constituted the definitive environmental assessment for servers under the 1680 framework. The negotiations collapsed.
Okay, but this is where I need to play detective, because this makes no sense to me. Why would servers, these massive, complex, enterprise-level machines that literally run the global internet, be so difficult to standardize under the IEEE 1680 umbrella that the ballot completely failed and a completely different entity had to swoop in and take over?
It is a massive failure of the system.
And speaking of that entity, the text says it was superseded by NSF 426. For those tracking the alphabet soup, NSF stands for the National Sanitation Foundation.
Yes, the National Sanitation Foundation.
Are we really talking about a sanitation organization? What on earth does a sanitation board have to do with enterprise cloud servers? Why couldn't the desktop engineering experts handle the servers?
That is the exact paradox we need to unpack. The National Sanitation Foundation, stepping out of the kitchen or the water treatment plant and into the hyperscale data center, might seem absurd at first glance.
It sounds like a typo.
But if we engage in a deep contextual analysis of what a server actually is, it begins to make perfect sense. We have to look at the fundamental physical difference between a desktop computer and an enterprise server.
Okay, lay it out for me.
A desktop, as we discussed earlier, is a standalone modular device used by an individual. Its power states, its life cycle, and its materials are relatively predictable and contained.
It sits on a desk. It goes to sleep when you leave.
Right. A server does not exist in isolation. Servers exist in massive, hyperscaled, multi-acre data centers. They are enterprise-level technology designed to run 24 hours a day, 7 days a week, without interruption.
They never sleep.
Never. And in doing so, they generate immense, dangerous amounts of heat. Because of that heat, servers require entirely different cooling architectures, often involving massive amounts of water, specialized chemical refrigerants, and facility-wide HVAC systems.
So it is not just about the box, it is about the building the box lives in.
Precisely. The environmental impact of a server is inextricably linked to the facility it is housed in. You cannot accurately measure the sustainability of a server without measuring the cooling tower on the roof of the data center.
That is a massive scope creep.
It is entirely plausible that the framework developed for 1680.1 which was designed to assess individual standalone desktop monitors, simply did not scale to the enterprise realities of liquid-cooled server farms.
They were using the wrong measuring stick.
The disagreements in the Valley Committee likely stemmed from a fundamental philosophical clash on how to measure efficiency. Do you measure the server hardware in isolation, or do you measure the server in the context of the data center's broader environmental footprint, including water usage and chemical coolants?
And the committee just broke apart over that.
This is where the NSF comes in. The National Sanitation Foundation has decades of expertise in auditing facility-level environmental impacts, water systems, and complex infrastructure.
Because they are used to dealing with industrial plumbing and sanitation systems.
Exactly. When the IEEE committee consensus completely fractured over how to handle these macro-level issues, nature abhorred the vacuum. The NSF possessed the institutional knowledge regarding facility-level environmental standards, and their standard, NSF 426, was adopted to fill the void.
That paints a vivid picture of a real turf war, or at the very least, a major philosophical clash in the world of tech standards. It proves that you can't just take the rules for a laptop and apply them to a massive server farm.
It is a completely different beast.
But as dramatic as the failure of the server standard was, the text reveals an even more mysterious failure right after it. Standard 1680.6, which was intended for complex set-top boxes.
This is where it gets really dark.
The text delivers a truly final, brutal verdict here. It says it never passed ballot and was archived. Archived.
There's a cold finality to that word. It didn't get superseded by another standard like the servers did. Another organization didn't step in to save it. It was just packed in a box and buried.
Swept under the rug.
Anyone who has ever tried to return a clunky, overheating cable box to their provider knows these things are a nightmare of proprietary tech. What exactly makes a set-top box complex? And why did the consensus completely fall apart here, leading to a total abandonment of the standard?
The word archived truly is the death knell for an engineering standard. It represents thousands of hours of committee work ending in total failure.
Why did it fail so hard?
To understand why this happened, we have to consider what a complex set-top box actually represents in the market. Think about the heavy cable boxes, satellite receivers, or proprietary DVRs sitting underneath televisions.
They are basically just heat generators.
Right. But unlike a desktop computer, which is fundamentally an open, general-purpose tool designed to run any software you choose, a set-top box is essentially a lockdown, highly restricted delivery mechanism for proprietary monetized content. It is a walled garden.
It is entirely controlled by cable monopolies, satellite providers, and global media conglomerates. The term complex in standard 1680.6 likely doesn't just refer to the physical circuitry.
What does it refer to?
It refers to the myriad of aggressively competing corporate interests inside that plastic box. You are dealing with digital rights management hardware, specialized proprietary decoding chips, and constant non-negotiable network connections required by the service providers to track viewing habits and deliver targeted ads.
So it is not an engineering problem, it is a business model problem.
Exactly.
I can only imagine the absolute chaos of trying to get 5 different telecom executives in a room to agree on an open environmental standard for a box they won't even let the consumer open.
It is an impossible negotiation. When you try to mandate environmental performance, which often requires open transparency about tower states, standby modes, and material composition on a device that is essentially a highly secured battleground for copyright protection and subscription delivery, you are dealing with a vastly different set of stakeholders.
They don't want to show their cards.
A telecom company might argue that a box must draw a high amount of standby power to constantly receive security updates and decrypt video streams.
And an environmental advocate would say that is ridiculous.
An environmental advocate would argue that is a massive, unjustifiable waste of global energy. We can deduce that the messy, uncompromising, deeply entrenched nature of telecom regulation simply broke the process.
The gridlock was total.
The industry could not agree on what green meant for a device whose primary unalterable function is to securely deliver pay TV while protecting corporate IP. The competing interests were simply too polarized, the ballot failed, and the effort was entirely abandoned and archived.
It is genuinely fascinating because it proves a point. You can easily get a room full of engineers to agree that a computer monitor should use less power and be easier to recycle.
That is the easy part.
But the very second you try to regulate the proprietary box that delivers the highly lucrative cable package, the negotiations completely fall apart. It really highlights that technology isn't just wires, silicon, and plastic. It is deeply entrenched politics, copyright law, and fiercely protected business models.
Technology is politics made physical.
Now, I want to take you, the listener, into what is arguably the most important, structurally significant part of this entire Wikipedia stub. We are going to do what every good researcher does. We are going to follow the footnotes.
The trail of breadcrumbs.
Because the footnotes often hide the most powerful information in plain sight. Let's look closely at reference number 3. It cites the Code of Federal Regulations, Title 48 Federal Acquisition Regulations System.
This reference raises an incredibly vital question, and it is perhaps the most critical insight in our entire deep dive.
Why is that?
Think about it. Why is a voluntary consensus-based engineering standard created by a non-governmental institute like the IEEE suddenly showing up in the codified law of the United States Code of Federal Regulations?
That is a massive jump in authority.
The implication of this single footnote is immense. It tells us that IEEE 1680 is not just a nice suggestion. It is not just a clever PR tool for tech companies to use in their marketing brochures. It has been legally embedded into the federal acquisition regulations of the United States government.
And the U.S. government is arguably the single largest purchaser of electronics on the planet. I want to break down the sheer economic gravity of that for a second. Let's imagine a hypothetical tech startup.
Okay, let's hear the pitch.
You have designed a revolutionary new desktop computer. It is incredibly fast, it looks beautiful, but it draws a little too much power and uses a glue that makes it impossible to recycle.
A nightmare for the 1680 standard.
Right. Now, if you just want to sell it to regular consumers at a retail store, you can probably get away with that.
Consumers might not care about the glue.
But if you want to sell 50,000 units of your revolutionary computer to the Department of Defense or the Department of Energy or the IRS,
you cannot make that sale. By writing IE 1680 directly into Title 48 of the Code of Federal Regulations, the government has declared an absolute mandate. If you want access to billions of dollars in federal contracts, you have to play by these specific engineering rules.
it is the ultimate stick.
The de facto standard we discussed at the beginning of the deep dives has been given the ultimate undeniable weight of federal purchasing power. It fundamentally alters the economic incentives of every technology manufacturer on Earth.
Because no company is going to pass up a government contract.
A company like Dell or HP isn't just designing a laptop to be green out of the goodness of their hearts. They are designing it to comply with 1680, because failing to do so locks them out of the most lucrative procurement contracts in the world.
So the government is basically forcing the market.
The government is effectively weaponizing its massive budget to enforce green computing globally. Because a company isn't going to design one compliant laptop for the government and a non-compliant one for the consumer. It is cheaper to standardize the entire assembly line to meet the federal requirement.
The government weaponizing its own budget to force global compliance. It is brilliant. But that brings us to footnote number 2. It references something called UL Empowering Trust Certifications. So we have the complex engineering standard negotiated by the IE. We have the massive economic mandate from the federal government in Title 48. And now we have this third entity called UL offering certifications. I know UL stands for Underwriters Laboratories, which most people might recognize from the tiny logo on the bottom of their lamps or extension cords.
The little circle with the UL inside it.
Yes, that one. But how does a theoretical standard written on paper translate into a physical stamp of trust that buyers actually look for?
A standard like IE 1680 outlines the criteria, the limits, and the testing methodologies, but the IE does not perform the testing itself.
Oh, they don't.
No, they write the law, but they do not police it. That is where independent testing organizations like UL come in. They provide the physical, verifiable infrastructure of trust.
They are the actual inspectors.
They take the highly technical rules written in the standard, they take the physical hardware shipped from the manufacturer, and they conduct the rigorous, independent laboratory testing required to verify compliance. The phrasing in the footnote, empowering trust, perfectly encapsulates their role in this ecosystem.
They are translating the math into trust.
They translate a dense, multi-page engineering document into a simple, instantly recognizable certification mark. When a federal procurement officer overseeing a multi-million-dollar contract or just a regular consumer in an electronics store sees that UL certification, they don't need to read the entire 1680 standard.
Nobody has time for that.
They don't need to understand the thermal dynamics of a power supply or the auditing process of a cobalt mine. They inherently trust that the assessment has been done by a neutral third party. The theoretical rule has been made tangible, verifiable, and consumable.
I want to connect all of this directly back to you listening to this right now. When you go out and buy a new laptop or a monitor or even a tablet, and you see that little environmental certification logo on the box, you are not just looking at a clever piece of marketing graphic design.
It is not just quip art.
You are looking at the visible tip of an enormous, deeply complex iceberg. You are directly benefiting from a vast, hidden infrastructure of regulation and negotiation. You are holding the physical result of intense, fiercely debated international ballots, strict third-party laboratory trust certifications, and the sheer, inescapable market gravity of federal purchasing regulation.
It is a massive cooperative effort.
All of that invisible machinery worked together behind the scenes to ensure the device in your hands meets the baseline of what humanity currently considers sustainable technology.
It truly is a remarkable hidden ecosystem. It is a system of checks, balances, engineering innovations, and massive market forces working in tandem to shape the physical reality of our digital society. It proves that technology is not just invented, it is negotiated.
It really is an invisible architecture. So, to summarize the immense journey we've taken through this tiny Wikipedia stub today, we started by defining the profound power of a de facto standard, exploring how the fiercely competitive tech industry voluntarily surrenders to a unified ruler at the desktop level simply to avoid the friction of chaos.
The path of least resistance.
We explored the philosophical evolution of Standard 1680.1, dissecting how the vital concept of social responsibility was introduced in 2018, ensuring that the human rights element of the global supply chain is no longer ignored in the pursuit of a green footprint.
A huge leap forward.
We marveled at the incredibly comprehensive nature of 1680.2, keeping a rigorous regulatory eye on everything down to the legacy fax machine in the corner office. We witnessed Standard 1680.3 holding the line on massive, power-hungry televisions, acting as a crucial speed limit on an industry obsessed with size and brightness.
Stopping the 800 horsepower TVs.
We ventured into the dark graveyard of standards, uncovering the dramatic ballot failures of 1680.4 for servers, and unpacking how the National Sanitation Foundation had to step in to handle the massive facility-level realities of data centers.
The sanitation experts saving the cloud.
We explored the archived, unsolved mystery of 1680.6 for complex set-top boxes, revealing how proprietary telecom interests and copyright protections can completely derail environmental progress. And finally, we followed the footnotes to reveal how these voluntary engineering rules carry the heavy, undeniable weight of federal law through Title 48, and how they are transformed into physical reality by third-party trust certifications like UL. We have fully decoded the green tech blueprint.
And as we conclude, I want to draw attention back to a crucial meta detail about our source material itself.
What's that?
The text specifically labels this article as a computer engineering-related stub. In the Grand Encyclopedia of Human Knowledge, a stub means the entry is fundamentally incomplete.
The story isn't over.
It means the full story of the standards that keep our technology sustainable is still largely unwritten and constantly evolving. And that leaves us with a deeply compelling thought to ponder.
I am ready.
The 1680 family dealt with the physical, tangible boxes we can see and touch, desktops, monitors, printers, televisions. But as our technology becomes increasingly invisible as we move away from local hardware and entirely into ubiquitous cloud computing, or look further ahead to the rapidly approaching era of wearable tech, microscopic smart dust, and even integrated neural implants, the nature of environmental and social impact changes entirely.
How do you certify a microchip in someone's head?
Exactly. How do you measure the footprint of a device that is embedded in the human body, who is currently sitting in a windowless committee room, fiercely negotiating and writing the environmental and social responsibility rules for the next generation of invisible, hyper-intimate tech?
That's a chilling thought.
And more importantly, given the dramatic failures in corporate stonewalling we saw with servers and set-top boxes, will those new rules survive the ballot? Or will they, too, be quietly archived?
That is a brilliant, slightly terrifying question to leave off on. The hardware constantly changes, but the complex, deeply human challenge of regulating it never ends. Thank you so much for joining us on this deep dive into the hidden rules of your devices. We hope you walk away looking at your desktop, your television, and even your old office printer just a little bit differently today. Keep questioning the invisible systems around you, and we will catch you on the next deep dive.